So we're carrying on with this light worksheet. So let's go over this quickly. Refraction. What is refraction? It's the change in direction of waves at a boundary. Okay. Number 2. You have a ray coming in. It's called the incident ray. You have a normal, which is at 90 degrees or perpendicular to the boundary. You can see you've got the air and the glass. You measure the angle of incidence to the normal. When the ray goes through, when it goes through the glass, it bends, it refracts, and that is the refracted ray. And then the angle of refraction is from that ray to the normal. I always get this wrong, and there's something else I think coming up or come up, but we'll sort that. What is the refractive index? Refractive index is how much material bends light. That's how we want to know it. It's given the symbol n, so n is equal sine I, the angle of incidence, over the sine of the refracted angle or angle of refraction. Number 5 we're looking at here. Right, okay, here's the electromagnetic spectrum from that book, from the Pearson book. You've got radio waves, microwaves, infrared waves. Radio waves have the longest wavelength. You've got radio, micro, infrared, and then you've got white light. White light is split up into Roy G Biv, red, orange, yellow, green, Roy G Biv, blue, indigo, violet. You've got ultraviolet, X-ray, gamma. Right. There's a mnemonic with this and I can't remember it, but maybe you can tell me. Right, longitudinal waves are waves where the vibrations are along the direction in which the wave travels. Transverse waves are where the vibrations are perpendicular to the direction of travel. Just learn these 2 definitions. Let's go. How far did we get? We did that. Right, okay, question number 5. Right. This question is about reflection of light. Light reflects in a plane mirror. Use the words from the box to complete the sentence. Less than, equal to, greater than. When light reflects from the surface of a plane mirror, the angle of incidence is, where are we? Less than, equal to the angle of reflection. Now, what does that mean? Look here, this is what they're trying to say. There's your mirror. The angle of incidence, so there's the incident ray coming in. We draw a normal, and then you've got the reflected ray. What they're trying to say to you is this is the angle of incidence and it equals the angle of reflection. That's what they're trying to say to you. Right, okay, let's move on. Right, the diagram shows 2 rays of light coming from an object. Continue the 2 rays and add further lines to the diagram to show how an image is formed with a plane mirror. Oh, right, okay, this is where it gets a bit. Ooh, how do we do this now? Right, okay, watch this. I'm gonna get ruler. Right, okay, I'm gonna get a ruler. I'm gonna draw a straight line in my head. I'm gonna draw that, and then I'm gonna carry this on at the same angle. Now I'm gonna end up getting this wrong, so it's come in, reflected, and gone up there. I'm gonna do the same thing with this one. So I'm gonna bring this. I hope I get it right. I'm gonna draw normal, perpendicular. So remember, this is 90 degrees. What color was it? Green. Okay, so I'm gonna try to get it by eye. I hope I get this. I hope I get this right anyway. So it's going up that way. Yeah, so it's coming this way and it's gone that way. Right, now what I do is I extend this. Right, I extend this. I'm gonna cheat a bit, right, but not too much. Right, I'm gonna just extend it that way, and then I'm gonna get the green, and I'm gonna extend it. I'm gonna cheat a bit there. Right. So what I do is I get a ruler. And then you know this line here, I'm gonna extend it using a straight line, and then I'm gonna get this. Let me pick another color. Let's just use should we use that? We'll use that. We'll just use that. So I'm gonna extend this line as well, and they're gonna meet here. They're gonna meet here. Now, if I've done that accurately, what's gonna happen is, look at this carefully. Can you see this distance here is going to be equal to this distance here, and that's where the image is. This is where the image is formed here, if that makes sense. Right. Right, that's it. The image in the plane mirror is a virtual image. How can you tell this from your diagram? Rays do not actually meet at the image. Yeah. So here, so look, these are the rays. And at the virtual image here, these rays are not meeting because they're over here. So we can say the rays do not meet at the image. Right, okay. Light can also reflect along optical fibers by total internal reflection. I think that's an important one. That. Give me 1 second. Right, total internal reflection is where what we can say is, how do I do this now for you? Let's have a look. Let's just start here. Right, you've got, we're going to call this glass. We're going to call this air. What I'm going to do is, let's try to understand this. Let's try to understand this. So you've got a ray coming in. Then we're going to draw the normal. And then it's going to come out. Nope. It's going to come out. Yeah, it's going to be refracted. I'm not quite drawn. I should have exaggerated it. Tell you what if I went a bit crazy and I did something like that? Right. Now, this angle of incidence, if there's something called a critical angle. Right. If the angle of incidence is greater than or equal to the critical angle, you get something called total internal reflection. Right, let me explain that. Hopefully I won't confuse you. So now watch this. This has come in and it's gone through. Now what I'm going to do is I'm going to move this here, this line here. Yeah, because I want this angle to be bigger. So now watch this. Let's do that again. Just bear with me 1 second. Right, so let's do that again then. So this time, this angle of incidence, I'm going to make it bigger. So the ray is coming at a bigger angle. So this now is the angle of incidence. And it's bigger, it's greater than the angle, this critical angle. Yeah, we'll just call it C. So what's going to happen is this ray is going to bounce off. It's going to be reflected. Yeah, it's going to be reflected internally. It's going to be totally internally reflected. It's going to have total internal reflection. That's when this when this angle is bigger than or equal to the total internal reflection. It's when the angle of incidence here, let's get this right, the angle of incidence is greater or equal to the critical angle. You get total internal reflection. Right. So what's going to happen is here you're going to get this. It's going to bounce down here, and then it's going to bounce up there, and then it's going to bounce down there, and then it's going to leave through there. So this is how your light or your communication can happen. This might be a bit of data that's floating through that, what is it called, optical fiber. Basically your broadband comes down here now. What are the two conditions for total internal reflection? What can we say? Right, that's another point I should have highlighted. Right, this total internal reflection only occurs when you go from something with a high optical density or oh god, my god, I can't spell optical now. I need to quit. I think my students are getting to me. I've done it again. I will get there. Never give up. Optically dense. High optically dense material, and this is low optically dense material. Yeah. So first of all, the ray has to go from a more optically dense. So the ray has to go from a more optically dense material towards a less. Did I just spell towards like that? Did I just spell towards like that? 1 second. No. Oh no, it's not playing up. It's playing up again. Right, 1 second. Right, let's try that again. Yes, it's working. Because sometimes it stops working on me. Material towards a less optically dense material. So basically it's going from air, it's going from a glass to air. So it's only going to bounce about in air. So this is more dense than this. And then the angle, then we have to say the angle of incidence is more than or greater than the critical angle. The critical angle is the angle at which total internal reflection occurs. That's all it is, right? Okay. And telephone signals can be sent along. What's one advantage of sending signals using optical fibers? So there's less heating. There's less heating. There's less. You can send more information or data per second because light travels much quicker through optical fibers. Right, okay, we're going to call it quits there because I think that was quite a heavy session. So have we said anything about total internal reflection? Do we need to write it down? I think we do. Right, okay, let's see if we can write that down. So total internal reflection. Total internal reflection occurs when the angle of incidence is greater than, if it's equal to, you get the refracted ray running along the boundary, but we can do that if we come across it. So the total internal reflection, which is normally you might see as TIR, occurs when the angle of incidence is greater than the critical angle. Okay, that's it. Next video coming up, inshallah.